Hey guys, welcome back to QST. So this is chapter 7 for the final. Alright, and let's begin. Given, they gave lithium and then they give the mass number and the atomic number. Okay, so I'm just gonna make some things clear. Let's say this is our element, okay? And then this is the mass number, okay? And this is the atomic number. Atomic number is the amount of protons, the number of protons. And then this one, the 7, which is the mass number, is the number of protons and neutrons, okay? So here, how many protons does lithium have? It's 3. Okay. What is the atomic symbol of deuterium? Okay, deuterium, for you guys' information, is deuterium is a stable isotope of hydrogen. So deuterium has one proton, one electron, and one neutron of hydrogen. But then hydrogen, here on top, so we'll be having two. Yeah, over here it will be two because one proton and one neutron. So that's two. Okay, and then we have one under, which is atomic number, which is because it's one proton. Okay. Okay. So okay. Yeah. Symbol. Okay. So first we have chlorine and chlorine minus. So we have 35 and we have 17. Okay. 35 is the mass number and 17 is the atomic number. 17 is the number of protons. Now protons, it'll be 17, okay? It's gonna be whatever is down, whatever is the atomic number is always a proton. And neutron, to find neutron, we do 35 minus 17, so we'll get 18. And electron will be 18 because it's Cl minus, so like we're adding an electron, okay? It's Cl minus. It's gonna be, because like if it was just Cl, electrons and protons are going to be the same. If it's Cl minus, then electron will increase by 1, and if it was Cl plus, electrons would decrease by 1. Okay, so in this case we have Cl minus, so it's going to increase by 1. And protons never change. Okay, Al, aluminium, 3 plus. So we have proton never changing, 13. 27 minus 13, we have 14. And since we're adding 3 protons, or yeah, so adding, so we have 10 electrons now, okay? Not adding protons, losing electrons, okay. Next one, sodium. We have 11 protons, stays constant. Neutrons 12, 23 minus 7. And electron 10 because we are losing electron. So it's 10 electrons here. And here 16 protons, 32 minus 16 neutrons. And electrons, we're gaining 2 electrons, so that's 18. Okay, that's it for this one. Okay, so choose a diagram that represents atom. Okay, so atoms, it will be balanced. We'll have an equal amount of protons and electrons on both sides. So we have in A we have 1 proton and 1 electron, okay? And B we have 1 electron, 1 proton. C is only 1 proton, we do not have an electron. D we have a proton but 2 electrons. And E we have 2 electrons and 2 protons. So the only balanced ones are E, B, A. So A, B, E. Choose a diagram that represents a positive ion. Positive ion has a positive charge, and here in C we have C we have P, proton only, so that's a positive charge, so that's going to be a cation, okay, or a positive ion. And now D has 1 proton but 2 electrons, so it has a negative charge, anion, so D. Okay. Number of protons in an atom is represented by its atomic number. Like I said, on top is the mass number and on top is atomic number, okay? And okay, the diagram that represents an atomic number, 2. So Z has to be 2. So whatever atomic number is 2. So protons is 2. So 2 protons here only one here. So the only right one is this one. Mass number of an element indicates the number of protons and neutrons in its atom. Like I said, the one on top, the mass number, represents both the number of protons and neutrons. Look at the model that represents an atom of atomic symbol 2-1. So when they say 2-1, it means there are two, there's two like nucleons. Nucleons is what is inside the nucleus, okay? So basically, this is the nucleus, and whatever is inside is called the nucleons. And mass number is 2. A total of protons and neutrons will be 2. So here there is 1 and 2. So yeah, only this one has 2 as mass number because it has 2 nucleons. Here there's 1, here there's 3, here there's 3, so it doesn't suit. An atom is represented by the atomic symbol Az. The letter A in the atomic symbol, like I said. Letter A, the one on top, represents the mass number. Letter Z represents the atomic number. And consider the atomic symbol of bromine, At35Br. Fill in the blanks of the numeral to determine the number of protons, neutrons, and electrons in a bromine atom. Number of protons, like I said, is always going to be the one below, or the letter Z, to be represented by the number of protons. So that is 35. Number of neutrons will be 80 minus 35 because mass number is protons and neutrons. And number of electrons, if it doesn't say anything like, if it's just Br, then the number of protons and electrons will be the same. But if it's Br plus or Br minus, it's going to change. The number of electrons will change. But here it's just Br, so they stay the same. Isotopes are defined as atoms of. Okay, so isotopes, they have the same atomic number but different mass numbers. So that means they have the same atomic number but different amount of neutrons, okay? So isotopes are defined as an atoms of the same element that have the same atomic number but different mass number. Look at the model that represents an isotope of hydrogen. Z is equal to 1. So Z, like we said before, we have A over here, Z over here. Z is the number of protons, Z is 1. So number of protons is 1. So only here and here we have 1 proton. The other ones, we have 2 here and we have none here. Okay. Okay, these are characteristics, okay? It is a positively charged particle. A proton is a positively charged particle. It is held in shells around the nucleus. So this is the nucleus. We have the protons and we have the neutrons here, okay? Like, electrons will be around, okay? Electrons will be around, like around the nucleus. It is different for isotopes of the same element. Neutrons, like we said, isotopes, they have the same atomic number but different mass number, so different number of neutrons. It has a negligible mass. Electrons have a negligible mass. You guys need to know that. You need to memorize that. Electrons, they have a negligible mass. And a neutral charge is neutron. Kind of evident. Neutron, neutral. Choose the correct answer to complete the following sentences. What represents a positive ion? Okay, a positive ion. So positive ion, let's see, we'll start from D. D here it's an atom, it's balanced. We have one positive, we have one proton, one electron, so no. Here we have 2 protons, 2 electrons, so no. We have 1 electron, 1 proton, so no. But here we have 3 protons and no electrons, so it's a positive charge, so it's a positive ion. And what are isotopes? Okay, in here we said isotopes have the same atomic number but different mass number. So what here has the same atomic number? B and D, because they have 1 proton, you see, 1 proton, and they have different mass number. What has a mass number of 4? So when they say mass number of 4, it is what is inside. inside the nucleus. So what has the mass number 4? This one has like 1, 2, 3, 4, 5, 6. So no. 1, 2. So no. 1. So no. 1, 2, 3, 4. Yeah, this one. Okay. Okay. A mass of a proton. Okay, you need to memorize this. Okay. The mass of a proton is 1 AMU. The mass of a neutron is 1 AMU. The mass of an electron is 1 over 1840 AMU. Nucleons are protons and neutrons. So nucleons is like what is inside. Nucleus, whatever is inside is the nucleons, okay? Atomic number of chlorine is, okay, so we said atomic number will always be the same. Atomic number 17, we have 17, which is the protons, so atomic number 17. Mass number of Cl, mass number is the one on top, so we have 35 over here, so it's going to be 35. The mass number of neutrons of Cl is, the number of neutrons of Cl is, okay, so number of neutrons is the mass number minus atomic number, so 35 minus 17, they get 18. Okay. Number of electrons of Cl is 17, while that of Cl minus is 18. Like I said, if it's just Cl without plus or minus, okay, then it's going to be the same number of protons and electrons. But here, if it's like minus, then it's going to be another electron, so 18 electrons, and if it's plus, it's going to be 16 electrons. Okay. What is the average molar mass of silicon Si? Okay, now here we have a rule. Okay, I'm gonna tell you. So when we have the average molar mass, when we need to find average molar mass, it's simple. So it's basically the percentage, okay, the percentage over 100. So we're basically making it a decimal, okay? Actually, wait, no. X, okay, times the isotope number. So here we have silicon 28, here we have 29, here we have 30, okay, so here 28 plus the next one, so x2, I would say 129 plus x 330. Okay, so if we put that in the calculator, we get, so we have 92.23 over 100 times 28 plus 4.670 over 100 times 29 plus 3.1 over 100 times 30. We are going to end up with 28.1087. So 28.108, when we make it 3 6 figures, that's 28.1. Okay. Chlorine has two stable isotopes, 35 over 17 and 37 over 17 chlorine. Assume the mass of each nucleon to be 1 AMU. The average molar mass of chlorine is 35.5. Okay, find the percentage of each isotope in nature. Okay, so what do we know about the percentages? They always add up to 100, right? So if it's always going to add up to 100, then we have two of them. Okay, we have two isotopes given. Then we're going to do x over 100. Okay, this represents the percentage of the first one. So x over 100 times 35, because it's the number of isotopes, plus 100 minus x over 100 times 37. So this is basically like whatever you find this to the percentage of the other isotope is 100 minus x. Okay, so if we do that, we have to do it on paper. Okay, yeah, and that is, oh, wait, yeah, this is an equation that will give the average molar mass of chlorine. So it is equal to 35.5. The total of all of this is equal to 35.5. Now we can do the math. Okay, now 100 denominator on both sides, so it's going to be x. We're going to simplify it to x over 35 plus 100 minus x over 100. Okay, now we can take this and multiply it over there. Okay, I'm gonna just, okay, so x over x, no, 35x, because it multiplied by 35x plus 37 times 100 minus x is equal to 35.5 times 100. So because we had that as fraction, remember, so 35.5 times 100 will be 3550. And now we distribute. Okay, 3700 minus x, so we're going to get 35x plus 37 times 100 is 37,000. Sorry, 3,700 minus 37x. Okay, so we can take the minus to this side, so it's going to be 3,700 minus 2x, because it's 35x minus 37x, so 3,700 minus 2x is equal to 3550. And now you take it to the opposite side, this one. So 3550 minus 3,700, so that will give you negative 150. But then since it's going to be negative on both sides, so negative 2x is equal to negative 150. Negative on both sides, just cross out the negative. 2x is equal to 150, x is equal to 75. So the value of the first isotope is 75. Okay, it doesn't matter where you give the x. Oh, and since the first one is 75, the other one is going to be 25%. Okay, because it's 100 minus 75. So 75 on for the first isotope, second isotope 25. Doesn't matter where you give the x. It can be for the first isotope or the second isotope. You will end up with the same conclusion. Okay guys, that's it for the chapter 7.1. 7.2 is not, I have been told that it is not coming, so I will not be doing a video on that one, and we will resume with 7.3. Alright, for chapter 7.3, it's just properties of the periodic table. So which of the elements are true about the modern periodic table? Elements in one column are called a group. Okay, so just so you guys know, we have a group, okay, and we have a column. Now, sorry, a group is also known as a column, and this is a period or a row. Okay, so this is a group or column, and this is a row or period. Okay, elements in one column are called a group. Yes. Each row in the periodic table is called a cell. No, each row is called a period. Elements in the same period have similar properties. No, elements in the same group have similar properties. Metals are on the left side of the periodic table. Elements are arranged in the periodic table according to their atomic number. Yes, so basically their number of protons. Okay, so this one, like I did in the last section, we're going to have number of protons equal to the atomic number 26. Mass, wait, what? Oh, okay, this is isotopes. Okay, so 26, and in the isotopes it never changes, or like the isotopes, not isotopes, sorry, whenever like there's a symbol next to it, whenever it has a charge, the protons never change, only the electrons change. So 26 remains 26. So so Fe3 plus, also the number of protons remain the same for all of them. because it's only the electrons that are changing when there's a difference in charge. The protons do not change, they remain the same. Number of electrons, here it's 26 because we have no charge. Number of electrons, Fe2 plus, we are losing 2 electrons, so it's 24. Fe3 plus, we are losing 3 electrons, so it's 23. Number of neutrons always also the same because it's mass number, it's mass number minus the number of protons, so 56 minus 26, so we get 30. It doesn't change, 30, 30, 30. Mass number, it doesn't change either, 56, 56, 56. So basically what is inside the nucleus does not change when there is a difference in the charge. Okay, to which group does iron Fe belong in? So this one, always make sure you have a periodic table in the exam. Okay, just check in the periodic table where iron Fe is, and we'll get into the details of the periodic table soon. A period is a row in the periodic table. Okay, yes, like I said before, period is a row, group is a column. Yes, transition metals are located between group 2 and group 3. So like we said, iron would be somewhere over here, the yellow part, okay? So it's transition metals between group 2 and group 3. Okay guys, that's it for 7.3. We'll go 7.4 now. Alright, for 7.4, it's properties. Okay, make sure you know the properties of everything: alkaline metals, transition metals, noble gases. Yeah, okay. I'm not sure about transition, yeah, but make sure you know all of them. Anyways, which of the following are not properties of noble gases? So, noble gases, they exist in nature in the monoatomic state. Yes, they do exist in the monoatomic state, which means they exist as one atom, okay? They're basically like single. Okay, they don't react, or they're just one. They're just one. Okay, they are inert, okay? Yes, they are inert. Their melting points and boiling points decrease down the group. Wrong, it actually increases down the group. Okay, so melting points and boiling points, they increase down the group. They belong to column 18. Yes, column 18 is the last column, and they belong to column 18, so that we cannot choose that because it's correct. And they are highly reactive? No, they're not highly reactive. They are inert. They do not react, okay? They are not at all reactive, so that is wrong. So these two melting points actually increase down the group, and they are not reactive. Okay, which of the following elements are noble gases? This one you can check the periodic table. Under group 18, we'll have helium, krypton, and neon, which are noble gases. Which of the following are true about noble gases? They belong to group 18, like we said before. Yes, in the last group, group 18. They are unreactive. Yes, they are. They are all kept under kerosene? No. Usually like potassium and sodium and all are kept under kerosene because they are highly reactive, but noble gases are not reactive, so they are not kept under kerosene. They react violently? No. When you see reactants, no. Whenever you see reacted noble gases, they do not go together. Okay, react violently with chlorine and produce a white solid? No. They react violently with water and produce hydrogen gas? No. Okay, the boiling point of noble gases increased going down the group. Yes, like we said before, it goes down, it increases. Not decrease, increase down the group. Okay, we'll go to 7.5 now. Yes, chapter 7.5 is just a lot of properties and stuff that you need to understand. So, which of the following are true about lithium, sodium, and potassium? So, basically, lithium, sodium, and potassium are alkali metals. So they want properties. So always like you need to memorize the properties of alkaline metals, noble gases, like I said before. Okay, so they are solid metals. They are not all kept in water. They are not all kept in water. They are soft. They react violently with chlorine, and they conduct electricity. Okay. Now, lithium chloride gives a red flame. Okay, you need to memorize all of these. Lithium chloride gives a red flame. Sodium bromide gives a yellow flame. Potassium iodide gives a lilac flame. Sodium reacts with water. Hydrogen gas is produced. Okay, so basically, a metal. When a metal reacts with water, a metal hydroxide plus hydrogen is produced. So a metal hydroxide plus hydrogen. Okay. Okay, for this one, well, I was informed that the first two questions are not going to come because we only did metal with water, although the first two are easy. So we'll be focusing on the last one. So write the equation of the reaction of potassium with water. Okay, so like I said, um, whenever a metal reacts with water, so metal plus H2O will give you a metal hydroxide plus hydrogen gas. Okay, so we have potassium plus water gives you, we already know we get hydrogen. It's always there's always going to be hydrogen, and we get a metal hydroxide, and it's potassium, so KOH. And now we just need to balance it. We have one potassium here, two hydrogen here, 2 plus 1, so 3 hydrogen here. Oxygen is balanced. Okay, so we need to balance the hydrogen, and to balance the hydrogen we can just make this one 2, but then that will make hydrogen all the way 4, and we'll have to make this one also 2, so 2H2O gets them balanced, but then here the potassium becomes 2, so 2 here as well. So now we have 2 potassium, 4 hydrogen, and 2 oxygen. Alright, it balances out. Alright guys, that's it for chapter 7. Hope you guys have a nice exam, and I hope you all understand everything. So good luck guys, bye.